Good morning, guys. We're going to go through page 5 of the Ratio 2H pack, and that's all about similar shapes. Now, similar as a word in English just kind of means roughly alike, but in maths it means something very different. It means something very precise. It means that you have two shapes whose ratio of corresponding sides are equal. Okay, so the ratio of these two sides, which correspond, so this one here corresponds with this one, is equal to the ratio between this side and the top one over here, its corresponding side. Okay, so in other words, one shape is an enlargement of the other. Okay, or each shape is an enlargement of the other. If you remember that enlargements can also make a shape smaller. So what we can do when we know this is find a scale factor between corresponding sides. Okay, so if you've got two obvious corresponding sides, you can use them to find the scale factor. So the scale factor in this case is 2, and we can use that to find any missing bits of information we need. If we want that longer side, that's going to be 2 lots of 8, so 16. Okay. Right, on to question B. So the corresponding sides we've got that give away the scale factor are these top two. Okay, what do we times 5 by to get 15? Now, these are obvious to begin with, okay, but if you didn't know what that number was, what you would do, hopefully, is divide this second one by the first one, and that method's going to come in really handy later on when we get to ones that are a bit harder. Okay, but hopefully you all know that this is 3. So when we do 4 lots of 3, that's going to give us 12. Okay, so you remember these are called the scale factors, and you can just put SF for scale factor. Okay, on this triangle, our corresponding sides that are visible are this left-hand side of each shape, and the scale factor there is that it's been times by 4. Now we need this missing side on the original shape, so actually we're going to need to go back. So we're going to divide by 4 to find that length, and that will be 3. Okay, and you can see that the hypotenuse of these triangles, and I say hypotenuse because they are right angle triangles, 3, 4, 5 triangle, they also adhere to this scale factor. Okay, on D, it's starting to get a little bit harder in terms of finding the scale factor. What do we times 2.5 by to get 15? Well, if you double it, you'll get 5. And then if you triple 5, you'll get 15. So in other words, we've times by 2 and then by 3. So we've times by 6. So we do the same here. 1.5 lots of 6 is 9. On this shape, how many 12s go into 60? That would be 5. So 9 lots of 5 would give us 45. They don't have to be drawn to scale, similar shapes, by the way. In most questions, exam questions, shapes won't be drawn to scale. These definitely aren't, even though it doesn't state that. Okay, so we've gone from 6 centimetres to 1.2 metres here. You've got to be careful. So that would be 120 centimetres. How many 6's go into 120? Well, if I double 6, I would get 12. Then I'd have to times by 10 to get 120. So I've times by 20. So I want to divide this by 20. And 2.5 20s go into 50, so that would be 2.5 centimetres. Okay, I can just do that because this is in centimetres, and so is this. Number 2, we are told that these two triangles are similar. Work out the length of DF. So these are exactly the same sort of questions. There's just not a box for something they want you to find. They've just used geometric notation. So first we've got to find the scale factor. So here's our corresponding sides that are going to give away that scale factor. And the scale factor is 4. So DF will be 6 times 4, which is 24. State the units as well. Okay, and the length of BC, so this one on the original shape. Here we're going to go back from this corresponding side. We're going to divide by 4. How many 4's go into 22? Well, 5 4s go into 20, and then we can get half of 4 into that remaining 2, so that's 5.5. Number 3, another 2 similar triangles. Write down the size of angle JKL. So JKL, this angle up here. Well, one of the things about similar shapes is that the angles are actually all equal. Just because we've made a shape's lengths bigger doesn't mean we've changed any of the angles whatsoever. In fact, all of the angles will be the same as their corresponding partner. Okay, all the angles in this triangle would add up to 180 degrees. Just because we've made the triangle bigger, they can't add up to more than 180 degrees. That just wouldn't be a triangle anymore. So angles actually remain the same. So this is just testing our knowledge of that. Okay, in fact, one of the ways to prove that two shapes are similar is to show that all of the angles are equal. Okay, work out the length of GI. So this bottom length, right, so now we need the scale factor, a little bit harder now. How many 9.5s go to 19? Actually, that's not too bad, that's times 1 by 2. So GI, I'm going to divide the length JL by 2, and that'll give us 11. And the final question, okay, so squeeze it on. Find the size of X. So, right, here's my corresponding sides. Now, this one not so obvious. So to work out the scale factor, I would do 15, divide it by 6, and that will give me 2.5, or I can just cancel down the fraction. I can divide both of these by 3, and that would give me 5 over 2. So sometimes just using fractions is easier. But of course, half of 5 is 2.5, so that's what we've times by. So all I need to do is times 8 by 2.5. And using the fraction, I'll show you an easy way to do this as well. So if we use the fraction, rather than times by 2.5, times by 5, and then halve it. Or halve it, and then times by 5. It doesn't really matter what order you do it in. So if I halve it, that would give me 4, and then times that by 5, that would give me 20. Might be sometimes easier than trying to think of what is 2.5 lots of 8. Okay, and B is so good, I've written it twice. I'm not sure I did that. Find the size of y. So we're going to divide by 2.5 here. Now, definitely easier to think about the decimal there, I think, because what would I need to do to that decimal to turn it into the number 25? I'd have to times it by 10. So if I'm dividing this by 2.5, my answer will be 10. Okay guys, thanks for watching. The questions get a bit more difficult on the next page, but hopefully it'll help.